You have come back, minions, math magicians, big and small. Of course, you wanted to know about this. This is a follow-up, a more general statement of the integrand that we did last video. If you're not sure how we dealt with it without this, go check it out. It hurt my brain. It might hurt yours. 'Twas messy. So let's come up with something else. We are going to prove this identity, which is a more general statement of what we had. 1 plus 2 times the sum of cos kx. So cos x, cos 2x, cos 3x, cos 4x in our case, would be sine of 9x over 2 over sine x over 2. This is actually called the Dirichlet identity. So let's go. Now, you may or may not be surprised to know that this is going to be using complex numbers. All right, because we know that cos kx is e to the I kx plus e to the I minus I kx over 2. All right? And that's what we're going to go with. So let's pop that in. Now the 2 and the 2 cancel out. Now, cool. Probably want to factorize something out here. And maybe not. Maybe not. Now, when we think about what we've got here, what have we got, really? We've got e to the minus I nx, e to the minus I n minus 1x plus da 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 da, e to the minus ix plus e to the ix plus da 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 plus e to the I nx. If I split all of these terms up, smallest, biggest, and move them in. Now, I am missing a term here. I am missing a term here, but I'm not, because 1 is e to the 0. All right, so I'm going to take that 1, and I'm going to pop it there, because what do we end up with here? We end up with a geometric series. We end up with a geometric series. We have a first term of e to the minus I nx. We have a constant ratio of e to the ix. And our number of terms here, unfortunately, we're going to have to reuse the n, so let's call this capital N, is 2n plus 1. All right? I get 2n from all of these terms plus 1. So we are all set to use what we know. We are all set to use what we know, if I can find an eraser. So, sum to infinity. I'll remind you, sum to infinity of a geometric is a times, let's go 1 minus r to the n over 1 minus r. Should we do that? No, let's do it the other way around. I think we want to do it the other way around. Let's do it the other way around. So, a, e to the minus I nx times r, e to the I nx minus 1 over e to the ix minus 1. Well, let's multiply that top out, because we are getting somewhere close to what we want. So that just becomes 1 minus e to the minus I nx. Okay. e to the ix minus 1. Oh, that's because my that's why that's not working for me. Because that is 2n plus 1x minus 1. There we go. Right. Let's multiply this through. Let's get rid of a bit of this, so I've got a little bit more room. That's e to the I n plus 1x minus e to the minus I n x over e to the ix minus 1. And what I'm going to do is I'm going to multiply the numerator by e to the I minus ix over 2, and I'm going to multiply the denominator by e to the minus ix over 2. The reason is I want to start trying to make some signs up here. So there's e to the I. So n plus 1 minus a half is n plus a half. X minus n minus a half is minus I n plus a half x. And that's already where we want to be. And the denominator becomes e to the I x over 2 minus e to the minus a x over 2. And here we are done. All right, divide the top by 2i, divide the bottom by 2i. And what we end up with is we end up with sine of n plus a half x over sine of a half x. N plus a half x is just another way of writing what I had at the beginning. And all of a sudden, if you go back and look at the integral we did last video, if we were aware of this identity, instead of playing around with all those weird trig expansions, we could have just gone straight to here. So as always, as soon as I see something that I'm using double angle formulae, compound angle formulae again and again and again and again, in my head I'm thinking there's got to be a complex numbers thing I can do here. And it turns out there is. So there you go. That's my little part B, my follow-up. Go see how this applies to the previous video. Please do. I am Nick. This was some maths. If you're still enjoying this, drop us a like, drop us a subscribe, comment. What do you prefer? Would you rather in an exam try and have a few of these under your belt, or just go like what I did in the last video with a bunch of identities? Let us know in the comments below. See you soon.